Hey, it's Jillian. We're going to take a look at multiplying binomials today. So we know if monomials means one term, binomials means two terms, 1, 2, 1, 2. Trinomials will mean three terms, and so on. So here we're going to multiply two binomials. We've got one binomial and we have another. So there's a method called FOIL, which is an acronym, FOIL. And what it stands for is you multiply out the ones that are first in the brackets, so t times t. Then you multiply the two outsides, so we've got t times -1 is -1t. Then we multiply the two inside ones, plus 5 times t is plus 5t. And then we multiply the last two, which is 5 times -1. So we have t times t is t squared. We have minus 1t plus 5t is plus 4t when we collect like terms. And then we have the minus 5t. So FOIL is really a commonly used expression. In fact, we've made it into a verb. We say FOIL out the brackets. So let's do that. Here I've got 6v times v is 6v squared, because that's really a 1 there. So 6 times 1 is 6, and v times v is v squared. Then we have 6v times 1 is 6v, 3 times v is 3v, and 3 times 1, both positive, are 3. And then we have these two to collect. Oops, I'm so used to writing x, you can imagine, plus 3. Okay, let me just fix that a little better. And here is an example of FOIL. Right here they talk about it. So let's continue to FOIL these out. X times x is x squared. That's 3x. That's 2x. That times that is 6. And in fact, you may find that you can go straight to doing this in your head after a little while, if not already, and just go straight to here. And what you'd be saying in your head is, if you had this and you wanted to FOIL it out, you would say that times that is x squared. That's 3x, and 2x is 5x, and that times that is 6. And that's kind of what you'd be doing in your head. So let's FOIL out these two binomials. So we have 6x times 2x is 12x squared. 6 times 2 is 12. X times x is x squared. Then 6x times minus 3y, so that's 18xy. Then minus 2y times 2x is minus 4xy. And minus times minus is plus 6y squared. Those are like terms, so let's collect them. Minus 18 and minus 4 is minus 22xy plus 6y squared. And that is multiplying out binomials. I'm just going to do a little bit more practice here. Sometimes there's a term in front that you're going to multiply in. Sometimes you will multiply out binomials, and then whatever you simplify them both to, you have a subtraction. So let's try some. So here, you know how this is a true statement? 1 times 2 times 3 is the same as 2 times 1 times 3. That order doesn't matter. When you multiply, you still get the same answer, which in this case is 6. That's true, no matter what you're multiplying. If you have three things, like we have here, we have 3 times that, order doesn't matter. So there's two ways in which we can do this. I'm going to demonstrate both, and then moving forward you can do either method. They're both equally correct. So one is write down the 3, put a big bracket, and then FOIL these out. So let's do that. 6 times 6 is 12x squared. That times that is minus 18xy. That times that is minus 4xy. And that times that is plus 6y squared. And then we collect these. keeping that 3 out here. So we've got 12x squared minus 22xy plus 6y squared. And then now we distribute that 3 in and multiply everything. So we have 36x squared minus 66xy plus 18y squared. However, we could also do it this way. Instead of multiplying these two out first, we could multiply 3 into this. So if that was the case, we would distribute 3 into this. So that's 3 times 6 is 18x, and 3 times that is minus 6y. And then we still have this second bracket here, 2x minus 3y. And then we would FOIL these out. And when we do, you will find you end up with the exact same thing, but I will show you. So 18 doubled is 36x squared, and 18 times 3 is, what is that, 54. Again, like always, if you don't have a calculator, which is perfectly fine, just do 18 times 3. That's 4, carry the 2, and that's 5, 54. So we've got minus 54xy. Then we have 6 times 2 is 12, minus 12xy. And then we have plus 18y squared. And then, of course, these two will add up. Minus 54 and minus 12 is another minus 66. And as you can see, they're the same. So really, you can do one or the other. I tend to do this mostly. I don't know why, I just kind of got in the habit of it, but this is also perfectly fine. Okay, now let's take a look at this one here. So this one, we have to FOIL this out, and then subtract what we get. So first is y squared minus 3y minus 4y plus 12. I'm going to put that in brackets. Minus, FOIL this out, y squared plus 5y minus 2y minus 10. Whoops. Okay. So now I'm going to collect these. So I've got y squared minus 7y plus 12. And here I've got y squared, and I've got 5y minus 2y is plus 3y. And now I'm going to remove the brackets. So when there's a positive sign, or nothing, which is the same as a positive sign in front of a bracket, you don't do anything. But when there's a minus in front, which is really a minus 1, I need to distribute minus 1 in and change the sign of everything. So I've got minus y squared minus 3y plus 10. And now I'm just going to collect. So now I have no y squareds, because y squared minus y squared is nothing. I have 7y, negative 7 and negative 3 is negative 10y. And then I have 12 plus 10, which is 22. And that's how you simplify something like that. Now let's take a look here at 4. Verify your answer to 3b by substituting 1 in for y. Okay, so what do they mean? So for 3b, here's what we're going to do. We're going to write this down. Y minus 4, y minus 3, which is this question we just did here, minus y minus 2, y plus 5. And we're going to plug in 1 for y. So let's do that. So we've got 1 minus 4, 1 minus 3, 1 minus 2, and 1 plus 5. And that is negative 3 times negative 2 minus negative 1 times 6. So what's negative 2 times negative 3 is positive 6, and then minus minus is plus, and 6 times 1 is 6, for a total of 12. Now let's take what this simplified to. Negative 10y plus 22. So negative 10y plus 22, when we sub in y equals 1, we get negative 10 times 1 plus 22, which is negative 10 plus 22, which is equal to 12. And indeed, we can see that these two are the same because when we sub in x equals 1, we get the same answer. Okay. Now let's take a look at this example here. Write and simplify an expression to represent the area of the shaded region. So first of all, we need to think. We need to think. If we can figure out the area of this sort of smaller inside white rectangle, and we can figure out the area of everything in this big rectangle, how could we add, subtract, multiply, divide, use some of this kind of math that we're learning to solve for this sort of like rectangular ring around here? Well, if we know the area of the whole thing and we take out the area of this middle, won't we be left with this area here? Sure we will. Okay, so let's do the area. I'm going to call this, there's the area of the big rectangle, and then we're going to subtract the area of the small rectangle to be left with the area of the rectangular ring. So let's see here. The area of the big is length times width. And then I'm going to subtract the area of this, which is 2y times 2y minus x. Length times width. Okay, so now I kind of have a question like I had up here. A product of two things minus a product of two things, except this isn't a binomial. That's really the only difference. So now here, let's multiply this out. That's 4y squared plus 2y plus 2xy. See, I put them in alphabetical order, plus x. And it's minus 2y times 2y is 4y squared, and 2y times minus x is minus 2xy. Now I'll get rid of my brackets. Nothing in here to collect, it's all different. And then here I've got minus 4y squared and plus 2xy. So let's take a look and see anything alike, anything like terms. Okay, y squared and y squared, so 4 minus 4 is nothing, that's gone. Then I've got a y here, and that's all I've got for y, so I'll put it down. Then I've got an xy here, and an xy here, so 2xy and 2xy's are 4xy's. And then all that's left is this plus x. So that is the area of the shaded region. So I'm just going to write shaded region equals that units squared, because it's area.